Hello, physics students. Todd Burke here. We're going to do some more trigonometry. This is our third video tutorial. And like I said before, math is fun. You don't have to like math, but I bet you agree that it's kind of satisfying to feel like, oh, I understood what to do. I got the right answer. You got your teacher off your back. You got your work checked off and done. And you're going to find that this is easy and you're good at it as long as you practice a little bit. It soon goes from being weird and unfamiliar to ordinary, just kind of something you do. And this tool is going to help us with sledding a little bit. So we we want to find the slope that we sled down. Maybe we want to find what's the elevation difference, the elevation loss from the top of the hill down to the bottom of the hill. Maybe we want to see what is that distance on a map, looking straight down a satellite view. Sort of we say as the bird flies. We can figure this part out, but we want to know like, okay, well, if I went straight horizontal on a map, how far is it from point A to point B? So in this case today, we're going to be interested in the function tangent. So to remind you, trigonometry is the study of right triangles. Every triangle has to have one 90-degree angle. There are some names that help us understand what we punch into our calculator, meaning which trig function to use. And those names are parts of the triangle. The side opposite the 90-degree angle is the hypotenuse. Let's mix things up this time and talk about the angle up top here. Really, to get good at trigonometry, you need to be able to see this triangle transposed and written a different way or flipped so that maybe the hypotenuse is on the bottom and it looks like this. And when that changes, people get confused. So we've done two tutorials with the same drawing, the same diagram using this angle. Let's say for today, for this problem, theta is this angle on top. 67.4 degrees. We'll do it twice. For the first problem, we'll pretend we know the angle already. So we've done a little tutorial with problems to solve using sine, and we had some examples for my second video using cosine. And so today we'll focus on the tangent function. SOHCAHTOA again is the memory trick to remind us which number is going to get divided by which number. These are all fractions. These are known for every angle, these ratios, just like pi is known. And even if you don't remember the whole decimal thing, your computer or your calculator or your phone does. And that's true of these sine functions. The sine for every single angle is known, it's in your calculator already. The cosine and the tangent for every one of these, as well as the inverse functions. Remember that sine has an inverse function, which we used when we pretended we didn't know the angle, and that was cosecant. Cosine has an inverse function, which we used when we pretended we didn't know the angle and we needed an inverse, and that's called secant. Tangent also has an inverse function we'll use with our second problem today. That second function is called cotangent. So SOHCAHTOA helps us just remember. So sine of theta equals the opposite over the hypotenuse. Cosine of theta, cosine of theta equals the adjacent over the hypotenuse. And then to calculate tangent, like we're going to today, the tangent of theta, we need to know the length of the opposite sides. We'll divide that by the length of the adjacent side. For the first problem, we'll say we only know one of those. So for the first problem, we're going to say we're interested in this triangle here, and we know that angle up top. We know this angle, and let's say we don't know this side. Maybe we don't even know this side. So we have then the angle in one side. That's just not enough information for us unless we have this access to the trigonometric functions. So with the knowledge in our computer or our calculator or our phone, we can actually find out what is the length here. Now, for this angle, we have a side touching it that's attached. That will be our adjacent side. So for this problem, I'm going to change this as well. For this problem, our adjacent side is here. And then on the far part of the triangle across, right, on the other side of the triangle here, we have the opposite side. So I'm going to just label that here so we aren't confused. All right. Now we know the length of the adjacent side and we want to find this one. So we're going to use the tangent function. Tangent of theta equals tangent of, in this case, 67.4 degrees equals the length of the opposite side, or unknown, divided by the length of the adjacent side, which is 5. So I'm going to write that out. Tangent of 67.4 degrees equals, why did that get messy? The opposite over the adjacent. My unknown, x, over the length of the known side there. My adjacent is 5. All right. SOHCAHTOA helped me plug the numbers into the right place, and my hard work is now done. I'm going to simplify it. Like last time, to do that, I want to have the x all on one side of the equation. So I'm going to multiply by this whole number. In order to be allowed to do that, I'm going to have to do it to both sides. Now this cancels, and I've put x alone on one side of the equal sign. I just simply need to figure out what is 5 times tangent of 67.4 degrees, and my calculator knows that. So I'm going to type in my iPhone 67.4. I'm going to hit the tangent button, and then I'm going to say times 5. And what I'm going to get is this length, which is 12. I think I get 12.001. So this equals 12. And now I know that side. All right. We're going to do the reverse sort of now and pretend we don't know this angle. So then if I don't know that angle, I can use the same knowledge in my calculator, what tangent is, right? And I can use the fact that I do know the lengths of both sides to find it. Do this with your own calculator and then pause it if you need to before I give the answer. See if you can confirm that I did it right. Okay, so I'm going to first of all set up the problem. I'm going to say the tangent, and I don't know the angle, so I'm just calling this theta. Tangent of theta equals the opposite over the adjacent. The opposite 12 over 5. Now, what I want to know is the angle. I want to know what theta is. So I'm going to have to divide the tangent out to get theta all alone. And that's weird, but it's helpful because it lets me cancel out this on the left, leaving only theta, which is what I want, the angle of the triangle here, the unknown I'm trying to find. So to do that, if you remember, you're going to put this simple division problem into your calculator. 12 divided by 5 will give you a number, 2 point something, right? And then you're going to press the second tangent button. Which is just a button. And then you're going to see the trig functions have changed a little bit, and now they say to the -1. And all you have to do is press it. And then that decimal, whatever that is there, will get turned into your answer. And in this case, it should be 67.4 degrees for the angle there. And now we've kind of gone through 2 different ways of using the 3 main trig functions. But actually what I did was with each video tutorial, 1 example of using the trig function and 1 example of using its inverse. In this case, that inverse of tangent is cotangent. And some of your calculators may actually have that button described that way. So here we go. Trigonometry is a study of right triangles. SOHCAHTOA helps you remember which fraction you're using. Each function represents a ratio, meaning the relationship between two sides. And they're always a division problem written as a fraction. If you can remember SOHCAHTOA, you can then sort out and plug in the information you have in order to find the unknown information you don't have and move on with your life. Thank you, trigonometry. I'll see you in class.